Hey everybody, this is Mr. Clapp.
Miss Funk.
Explaining some of your axolotl crosses. So our goal here is to demo for you how to do the last bit of your portfolio where you're going to explain an axolotl cross just like we do. You're welcome to do any cross except for the one that we're about to show you. And we're going to go through and talk to you a little bit about cross D, the one we kind of spent a lot of time on in class. You can do any of the other crosses. Probably stay away from F and G because we don't have a lot of the detail there. But any of the other ones will work. So, all right, so let's go ahead and talk about kind of what you're expected to do. So go ahead.
All right, so for cross D, we're going to show you a couple different things. We're going to show you photos of both parents, representative photos of the offspring, a table that describes the ratios of the phenotypes for our offspring, an explanation of the possible crosses that would explain cross D in terms of melanin and iridophores, and then also we're going to look at GFP and do the same thing.
So we know you're excited, and we are too. Let's do it. So to begin with, our parents for cross 1, the first parent was a golden male and a GFP golden at that. So this parent, being a golden, can't make melanin, but can make iridophores, and since it's a GFP, can also make the glowing characteristic that GFP allele gives. Our other parent in this cross was so this parent can make iridophores and cannot make melanin. So we see that variation there showing one of the dominant characteristics and not the other. And this parent also glows, so they have that GFP allele as well. The other parent, the female, was able to make melanin and iridophores. It was a wild type. You can see the gold flecking on it as well as the melanin obviously there. But this parent can't make GFP, so therefore doesn't have that characteristic.
So with both of those being our parents, we saw a couple different things for our offspring. So for our offspring for this cross, we saw some goldens, right? So can make iridophores, can't make melanin, and we counted 25 of those, which made it about 51%. And then we also saw wild type, which we counted 24 of those, so 49% can make melanin and can make iridophores. The thing that we can't see yet for our offspring is that GFP characteristic. They're not old enough, so we'd have to wait a little bit to know anything about that and the ratios for offspring for GFP.
By the way, this 25 and 24 number is in this picture. We just took a representative picture, or a sample, if you will. If you guys have different numbers, they're still going to be close to that 50-50-ish, but your numbers could be different. Okay, so explaining melanin. So let's start by talking about what these parents can do and eliminate some possible crosses that don't work for us. So parent 1, of course, can't make melanin, and parent 2 can. So if we look at our possible crosses, we know that parent 1 has to be homozygote recessive for melanin, or little m, because it can't make it. It doesn't have any copies of the dominant allele. For parent 2, we're just not sure, right? It could be homozygous dominant, or it could be heterozygous. Either one would result in a parent that can make melanin. So the possible crosses that work for this end up being a few of them, right? But we can start by, like we did in our worksheet, eliminating the ones that we know it wasn't. Possible crosses 2, 3, and 6 all had both parents showing the dominant characteristic, in this case being able to make melanin. Since that's not the case, we know none of those make sense. Possible cross 5 also doesn't make sense because in that case, neither parent makes melanin, and we know one of our parents did and the other one didn't. So the only two crosses that it could be are possible cross 1, where one parent is homozygote recessive and the other homozygous dominant, or possible cross 2, where the first parent was homozygous recessive and the second parent heterozygous. So we have to look at the offspring to figure out which of these two it is and look at some Punnett squares. So here we go. Here's possible cross 1 as a Punnett square. So you can see here in cross 1, we have parent number 1 at the top with that homozygote recessive characteristic and parent 2 at the bottom. When we drop in our alleles, what we see for this first possibility is a heterozygote, is one of the 4 possibilities, and it doesn't take too much to figure out that that's actually the only possibility we have. One parent's always going to donate the recessive allele, the other one always the dominant. So what does this mean? Well, it means 100% of our offspring from this cross would be heterozygotes. 100% of the offspring would show melanin, and since our cross had about 50% able to make melanin and 50% not, this isn't really consistent with what we saw. So we can eliminate this cross pretty strongly, given that a lot of our parents were able to make melanin, but not all of them. Half of them weren't. And so this probably isn't what we have. So let's take a look at possible cross 4. Hopefully this one works for us because it's our only other possibility. And again, if we drop in our alleles here, we see half of the offspring here would be heterozygotes, and the other half are homozygous recessive. And if we think about it for a minute, we realize the heterozygotes can make melanin, and the homozygote recessives can't. So this is consistent with our results, and therefore this is probably what we had. We probably had a heterozygote for melanin production and homozygote recessive for the other. So one last time, sort of reviewing the same thing, we went through and eliminated these crosses based on parents that didn't match, leaving us with these two, and then we eliminated cross 1 based on offspring, and so we concluded that possible cross 4 is what we must have had here, where we had a homozygote recessive, a homozygote dominant with regards to melanin. Ms. Funk's going to take over and talk about iridophores.
All right, so now we have to look at iridophores, right? So our first parent can make iridophores, right? We have that golden albino. We know that that's what they can make. And our second parent can also, right? Wild types make both that melanin and the iridophores, so we're clear on that. Since the ability to produce iridophores is dominant and parent 1 can make iridophores, right? So they have that gold color. They're either homozygous dominant or heterozygous and showing that dominant phenotype, right? And the same is true for parent number 2. It can make iridophores, and therefore it's either homozygous dominant or heterozygous. So, same thing that we just did with melanin, right? We're going to look at some possible crosses. So possible crosses 1 and 4 have one parent that show the recessive characteristic, right? They're homozygous recessive, and one parent that shows the dominant. So we can eliminate both of those crosses because both of our parents can make iridophores. And then possible cross 5 shows both parents unable to make iridophores, right? They both show the recessive phenotype, and we can eliminate that possible cross because that's also not what we see for our parents. So what can we look at, right? We either had possible cross 2, possible cross 3, or possible cross 6 because all 3 of those crosses show both parents able to make iridophores. So let's eliminate those same way we did just a second ago using some Punnett squares. So if we look at possible cross 2 first, one parent is going to be heterozygous at the top there, and then parent number 2 is going to be homozygous dominant, right? So if we drop in our alleles here, we're going to show first one being homozygous dominant, right? And then because that parent number 2 is only going to be able to give that dominant allele, right, we can see we have half being heterozygous and half being homozygous dominant. What that means is that 50% of the offspring, right, would be homozygous dominant and 50% heterozygous, but all of them would be able to make iridophores, okay? And that's consistent with what we see for our offspring. So this is a possibility, but we have to check the other crosses to make sure that we know exactly which one it is. So we'll look at possible cross 3 next. Okay, we went through possible cross 3 without a Punnett square because we can talk about it and know some stuff. So if we cross 2 parents that are homozygous dominant, right, for iridophores, all of the offspring would also be homozygous dominant. Those are the only alleles that either parent can give. So if 100% of these offspring would be homozygous dominant, 100% of the offspring would show the ability to make iridophores, and that's also consistent with what we saw for our offspring. So we can also have this cross. We haven't eliminated either one. So possible cross 2 and possible cross 3 both make sense. So let's make sure that possible cross 6 is also not one that we can look at. All right, so possible cross 6, both parents were heterozygous. Okay, so we can fill in these Punnett squares where we drop in our alleles. First one would be homozygous dominant, can make iridophores. We have a couple of heterozygotes in there, and then the important one here is that we have a quarter of our offspring that are homozygous recessive, right? So they can't make iridophores. Because 25% of our offspring can't make iridophores, right, 50% of the offspring would be heterozygotes and can make iridophores. 25% would be homozygous dominant and can make iridophores. That's not super consistent with what we saw, right? We saw all of our offspring able to make iridophores. So this possible cross we can eliminate, right? So just for melanin, we can eliminate possible crosses 1, 4, and 5 because of what the parents look like. We can eliminate possible cross 6 because of what we saw for our offspring, but we don't know whether or not it's possible cross 2 or possible cross 3. We can't tell until we had more information, right, which we don't have right now. So next thing we need to talk about, Clap's going to talk about, we're going to talk about GFP.
Hey, I want to say one more thing, just because it's kind of fun. That possible cross 6, Ms. Funk is absolutely right. We can totally eliminate it, but only kind of, because it is possible that we got some really, really weird statistics thing going on here, where we did have 2 heterozygotes, but every single time, just by dumb luck, one of the parents donated those dominant alleles. And so maybe we had 2 heterozygotes, and just by dumb luck, they never happened where both parents did that 25% probability where they both donated the recessive allele. The thing that makes this really unlikely is we had lots and lots of offspring. If we had a cross where we only had 2 kids or something, and they both showed up with a dominant characteristic, we couldn't eliminate crosses. But because we have a really big sample size, we actually can eliminate, which I think is kind of cool. Or we get closer to eliminating it, if you will. Okay, GFPs. So GFPs, parent 1 can glow, parent 2 can't. So therefore, parent 1 is either homozygous dominant or heterozygous for it. Can't tell by looking at her because either one shows the same characteristic. And looking at him, that's our male parent. And our second parent must be homozygote recessive because if she had a copy of it, she would be showing it. So we can again go through and eliminate several of our possible crosses because they have either both parents able to or both parents not able to show it. And so we know we either crossed the homozygote recessive times the homozygote dominant or the homozygote recessive times the heterozygote. This is just like melanin, coming back through one more time. It's a very similar situation. So we don't know which one it is. And to be honest, we haven't seen our offspring yet. So that's what we're kind of left with, right? We know it's either possible cross 1 or 4. And we can't tell until we see the offspring which of those 2 it is. If all of our offspring glow, which would be kind of cool, we know that that parent is homozygous dominant for that GFP characteristic, and all of the offspring are heterozygotes. If half of them do it and half of them don't, then we know that parent was a heterozygote, and resulting in half of the offspring doing it and half of them not. So once again, finalizing this, we can eliminate a lot of the crosses based on parents. These ones all because they both show the characteristic, this one because neither do. And again, just like that last one, we just don't know the answer here. It's either a homozygote recessive and a homozygote dominant, or a homozygote recessive and a heterozygote. So folks, this is pretty much what you have to do going forward on your own. Good luck, and if you have questions, feel free to ask us.
Yep. Use the information that you have, tell us the information that you have, and make sure that you're working all the way through it. Good luck, guys.